Hello, hello, hello. Because of the cantankerous personality and its acknowledgements from the past that I had hitherto, and for the sake of my videos for the YouTube channel, I am recording this short video so as to enlighten about what is really going on. And well, I have never made the promises real. So that is going to be a problem for some now, and I might be impeachable for doing such a thing, and maybe not a preference actually, but this is all about the vicissitudes of life occurring inevitably and expeditiously, and which even you have all precautions done so as to prevent that very eventualities in the life, then everything is going to be all in vain. So that is actually the reason why I am recording this short video. I hope it will be short, that I am going to share something like mention about the plans of our channel, that we are going to record cosmology. Yeah, it's supposed to be done in the semester plan. It never, so it couldn't. I mean, I haven't find that very opportunity to do such a things I promised, and I might be impeachable for that. I am pretty sure of this. But prudentially, I dare say that we can record something about cosmology in 2 or 3 weeks, and it's all about the inflationary cosmology, which will be recorded in both two languages, and yeah. And the others are actually for summer plans that I'm going to start for quantum mechanics or maybe electrodynamics, so as to review the methods that we are in requisition of, so as to keep going with the cosmology, that we are going to investigate light beams. Why? Because we receive as the sources of the universe, like stars. So the sources in the universe are actually prerequisites, so as to understand the theory and compare the consequences. And that is actually the reason why I am recording this, because theory is, as the greater physicists once said, that the theory take you only so far, and so on. I'm not experimental, by the way. I mean, I don't like experiments at all, but I will record. I have to record, otherwise we couldn't find an opportunity to compare our definitions towards the systems for which we are investigating in cosmology and which we are diligently calculating. That is requisition, and we have to do this. We have to do this. That's all. For now, maybe quantum mechanics will be recorded afterwards, all of these things, because they are important, and they are compulsive, which we cannot ignore easily, and that's important, yeah. And it will increase our sagaciousness, by the way. That's all. I am so busy, by the way. I mean, the lectures of those 2 years were actually amazing. That I have. Well, my deductions towards the physics were actually completed. Maybe in the level of undergraduate level, but they are amazing. I don't know why I'm recording this. I feel good, yeah, to be in a physics department, because it's like a tiny connections and boundaries between the bifurcated areas in the physics, or maybe anything. You are just explaining everything with equations, as you can see behind, and just try to connect them. That's all, and your justifiable assessments will be done. That's the greatest thing I have ever done in my life, the physics. Yeah. Okay, for cosmology, we intend to do that. You know the topics we will discuss in cosmology. It's all about inflationary cosmology, and it's about the gravitation, which is not stationary gravitational field, which is increasing by time, which is evolving by time. The field is not stationary anymore, and which is grows because of the expansion of the universe, which corresponds that there is some kinetic energy that extends to the infinity, for our assumption that it's going to infinity, but not true at all. And there is some restoring force, and this is actually the gravitational attractions that tends to universe to be slowed down. And those are the actual reasons. Those are actually not the actual. Those are the reasons why the universe is expected to be slowed down until 1998. But expectations are inconsistent with observational data that were completed near 2000s or so. We are going to doing that. So what we have done hitherto, we have done that the gravitational field that was expanded, or it was for the first time, for the sake of the cases to be easy to understand, it was stationary gravitational fields. And we expressed, by the way, we defined the motion of particles, which were actually the galaxies, the massive objects. They are embedded and bounded into the gravitational potential, which is constant. And we just explained the behavior of it, which is that actually the circular orbit or elliptic orbit, doesn't matter. It does take place where the momentum, the angular part, and the linear part is important. So you are just checking the net forces actually. But for non-stationary fields, what we did was actually writing down the equations which are evolving by time, because the time is necessity that you are observing some change in manifold or whatever, and you explain it by the space. You use the space as a tool, and the time is what the requisition of yours is. And that is actually something you cannot ignore. So others was actually the mass that it interacts, or maybe charge. It's supposed to be charge better, because mass is consistent of millions of charges. Well, the dense matter is charge natural, okay, but it doesn't mean that it does not include the atoms. They are the charge systems, right? Okay, whatever, we won't investigate it for now. It will be the issue of electrodynamics. Why electrodynamics? Because I intend to show you something about how the electrons are oscillating, or any charged particles, and what it causes. The light beams, the electromagnetic fields, and the fields are interacting with other particles, affecting their motion. And the energy, the linear momentum, or maybe circular polarized waves, plane waves. Doesn't matter. We will investigate them. We have to do this. Thank you.